Serialism is a compositional technique that uses a fixed series of a particular musical element as the basic construction of a piece. Broadly speaking, any music that utilizes a set repeating pattern can be considered serial, but the term is most commonly associated with atonal music. Isorhythmic music, for example, uses repeated rhythmic patterns and thus can be considered serial. Today we are talking about a special type of serialism called 12-tone serialism. Pioneered by the acclaimed composer Arnold Schoenberg in the early 20th century, 12-tone serialism is a technique that takes the 12 notes of the chromatic scale and places them into a fixed order, with each note given equal importance. This creates what is called a tone row, the basis for a 12-tone piece. In Schoenberg's own words, it is a procedure in music construction which seemed fitted to replace those structural differentiations provided formerly by tonal harmonies. He called it the method of composing with 12 tones, which are related only with one another. A bit excessive, but it works. In simpler terms, 12-tone music is a system designed to give atonal music a sense of order and cohesion.
We must first briefly examine the classification of notes within 12-tone serialism. The easiest way to do so is through a tool known as the clock face. Each of the 12 notes in the chromatic scale are placed upon a clock face. This connects each note with a number known as a pitch class, or PCs for short. We use the clock face to quickly and efficiently identify and compare pitch classes within a 12-tone piece, and to transpose between different tone rows.
A tone row, as mentioned previously, is an ordering of the 12 chromatic notes, or pitch classes. The notes in a specific tone row should always appear in the same row, and no note is repeated until the tone row has been stated in full. Composers use a 12 by 12 matrix to keep track of rows. The top row contains the first row of the piece. We label this row as PX, where X is the pitch class number of the first note in the row. The leftmost column contains the inversion of the first row, starting on its first note. This row is labeled IX, where X is the first pitch class number of the inverted row. To find IX, you must first find the transposition from each number to the next along your PX row, and then apply that line of transposition oppositely down your IX row. Another cool thing about a 12-tone matrix is that your X will appear diagonally from the top left to the bottom right. We will show this whole process in an example. Once the first row PX and the leftmost column IX and the diagonal X are filled in, we can fill in the rest of the matrix using transposition.
For our example, our X will be 6. First, you will find your P6 by determining the order of the first 12 tones of the piece you are analyzing. In this example, we are using Anton Webern's piece, Wie bin ich froh. This makes the P6 row read 6, 5, 2, 4, 3, 0, 9, 1, 8, E, T, and 7. Using the inversion method we talked about earlier, we know that the line of transposition for P6 is as shown. We fill out I6 by applying this line oppositely. For example, 6 to 5 is a T11 transposition, or more simply, to the left one space on a clock face. So, oppositely, we would apply a T1 transposition to 6, or move one space to the right on the clock face, to get 7 as our next I6 number. Continuing this process will get us the rest of the I6 row, which reads as follows: T, 8, 9, 0, 3, E, 4, 1, 2, and 5. We also know that our X, which is 6, will appear diagonal from the top left to the bottom right. That will look like this. Fill in the rest of the matrix cells line by line horizontally by transposing the first PX row of the piece. If done correctly, the diagonal column that stretches from the top left to the bottom right should consist of the same number stated 12 times. Once the matrix is filled completely, label the rows vertically on the rightmost side as Rx, where X is the pitch class number of the last note in the row. Similarly, fill out the rows below the last row of the matrix using Rix, where X is the pitch class number of the last note in the row. Rx, or retrograde, is a PX row read backwards. Rix, or retrograde inversion, is an Ix row read backwards.